Hello dear students, welcome to ECE Academy Benefactor. In this class we will be seeing advantages of negative feedback. In the previous class we have seen only the titles or the headings of advantages of negative feedback. We will be going in detail about each advantage in our next videos. In this class we will be seeing only stability of gain. So, let us quickly read what are the advantages of negative feedback: stability of gain, reduction in distortion, reduction in noise, increased bandwidth, increased input impedance and decreased output impedance. So, today's topic is stability of gain. So, what do you mean by stability of gain? What is gain? Gain is output by input. Gain is denoted by A. Gain is output by input. Okay. So, this gain can be of 4 types, that is voltage gain. What is voltage gain? V naught by Vi. Current gain AI. AI is equal to I naught by II. Transconductance GM is equal to I naught by Vi. Trans resistance gain V naught by II. So, these are the gain. Gain means output by input. So, AV, AI, GM, RM, these are gains of basic amplifier without feedback. Now, if you take gain with feedback, they will be written as AVF, AIF, GMF and RMF. Voltage gain with feedback, current gain with feedback, transconductance with feedback and trans resistance with feedback. Now, the equation for AVF will become V naught by Vs. So, this I will change to S and AIF will change to I naught by Is and GMF will be equal to I naught by Vs and RMF is equal to V naught by Is. So, in this way you are having gain without feedback and gain with feedback. So, the basic need for an amplifier is the gain should be stable, it should not fluctuate or it will create annoying to the audience, because amplifiers are generally used in public addressing system. So, the audio output must be clear enough, that is the amplified voice must be clear enough, it should not be annoying. So, the main requirement is gain is to be stabilized, that is stabilized by using negative feedback. And we have seen what is negative feedback. When the feedback signal is in opposite phase with the incoming signal, it is known as negative feedback. Okay. The gain of an amplifier, why it changes? Because of many reasons. Sometimes due to change in power supply, the amplifier gain may change due to change in power supply voltage, or change in parameters of the active devices of FET may also change, like HFE and all that may change due to change in temperature or due. So, these are the two basic reasons why the gain of the amplifier changes: due to change in power supply voltage or due to change in the parameters of the active device like FET or transistor, which are the active devices. If it is an amplifier designed using transistor, is it an amplifier designed using FET? So, the parameters of the active device may also change the gain of the amplifier. The adversely affects, what happens due to change in power supply voltage or change in the parameters of active devices? The performance of the amplifier gets affected. This adversely affects the performance of the amplifier. It would have been ideal if the gain of the amplifier was independent of these changes. Ideally we are saying that it's independent, but practically what may happen due to change in power supply voltage or due to change in parameters of the active devices, the gain of the amplifier may not be stable. So the basic need is to stabilize the gain. Thus, the gain AF of the feedback amplifier is made independent of the internal gain capital A. How is made independent? Because AF is only dependent on beta. It is made independent of internal gain A by taking the assumption that A beta is very large compared to 1. The gain AF depends only on beta, which in turn depends on passive elements such as resistors. The values of the resistors remain fairly constant and hence the gain is stabilized. This is one way of making the gain stable. Even if we make A beta very large compared to 1, condition is not fully met. So let us say that it is not fully met. Some improvement occurs in the stability of gain. But there is another way of understanding this concept of stability of gain. Let us look at the second aspect now. Okay, so one assumption is that you are making A beta very large compared to A. So the gain of negative feedback AF is equal to A by 1 beta. By applying this assumption, AF is only dependent on beta, that is depending on passive elements, which is moreover more stable compared to this gain A, internal gain of the amplifier. Now let us see the second scenario. Suppose a certain change in the internal gain of the amplifier takes place, that is A is changed by a fractional amount, suppose let us say by dA by A. There is some fractional change of internal gain. Internal gain here is A. We find the corresponding percentage change in the overall gain of the feedback amplifier. So the gain, this is a gain of negative feedback. What is the equation of negative feedback? AF is equal to A by 1 plus A beta. Now what we are saying in the second assumption, that due to certain reason this internal gain is changed. So what is a fractional change in the gain with feedback? Let us try to understand. For that we need to differentiate this equation. Negative feedback achieves this object to a great extent. What is objective? The gain of the amplifier is to be stabilized. How we can stabilize the gain? By implementing negative feedback to an amplifier. That's written here. The negative feedback achieves this objective, that is the stability of gain. So what's the gain of negative feedback? The gain is given by AF is equal to A by 1 plus A beta. This is a gain of negative feedback, where AF represents the gain with feedback and A is the gain without feedback and beta is a feedback ratio. So how can we make stability of the gain? Is one way of doing it is, if we make this A beta value very large compared to this one, what will happen? What will happen? That A beta is large, so 1 becomes negligible. So we can write this equation, if 1 is negligible, this 1 is negated. So this AF equation now becomes A by A beta. A get cancelled and it is equal to 1 by beta. Now this gain with feedback, that is with negative feedback, is no more depending on gain. It is purely depending on beta. What is beta? It is a feedback ratio. It is based on few passive elements like resistors. So the one way of stabilizing the gain is by making A beta value very large compared to 1, so that AF becomes independent of A and depends only on beta. And resistor means it's a passive element, so there will be no much fluctuations and the gain will be stable. AF is equal to A by 1 plus A beta. DAF by DA, differentiating both the sides with respect to DA. DAF by DA is equal to A, this denominator goes up now, 1 plus A beta, D by dA of A minus A times of D by dA of 1 plus A beta by 1 plus A beta the whole square. 1 plus A beta is written as it is, dA by A dA, this term is 1, so it's written as 1, minus A dA by dA. So first term is d by dA of 1, what it will be? It will be 0. And what is d by dA of A beta? It is equal to beta times of dA by dA, which is equal to beta. So here we are having 0 plus beta. So what it is written? This is 0 plus beta means this term is beta. So it's left with minus A beta. So you are getting DAF by DA is equal to 1 plus A beta minus A beta by 1 plus beta the whole square. Okay. So here these two get cancelled. We are left with 1 by 1 plus A beta the whole square. Okay. So you can write DAF by DA is equal to this one, and again we have splitted the square into this 1 by 1 plus A beta dot 1 by 1 plus A beta. And what is gain of negative feedback equation? AF is equal to A by 1 plus A beta. A beta. So what is AF by A now? It is equal to 1 plus A beta. So what is 1 plus A beta? AF by A. So we have used this term 1 by 1 plus A beta as AF by A into 1 plus A beta. So we are getting DAF by DA is equal to AF, and then bringing this AF term here. So we are writing DAF by AF is equal to this term we are taken here on this other side and writing this dA is taken here dA by A. So we are getting the equation DAF by AF is equal to 1 by 1 plus A beta dot dA by A. What is this DAF by AF telling? Is a fractional change in AF, and dA by A is a fractional change in A. This is a open loop gain and this is a closed loop gain. Gain without feedback and gain with feedback. Okay. So what do we observe? This is a fractional change. If you talk in terms of percentage, so we can say, and this value is definitely going to be greater than 1 this term. This 1 plus A beta will be greater than 1, है ना? So 1 by something greater than 1 will give some value. Since A plus beta is very large compared to 1, the percentage change in AF is seen to be much less than the change in A. So what we observe, as this 1 plus A beta is going to be definitely greater than 1, the percentage change in AF is going to be very, very less compared to the percentage change in A. Okay. So we have understood how can we attain stability of gain using negative feedback. What's the first one? The first concept was telling about to make this A beta very, very large compared to 1. Why the gain of the amplifier changes? Due to change in power supply voltage or due to change in parameters of the active devices used in the amplifier. Because of these two reasons, the gain may change. The gain may not be stabilized. So there are two ways to stabilize the gain. One is by making A beta very, very large compared to 1, and again even if there is a fractional change in gain due to certain reason, and then we found by this derivation that the fractional change in gain AF will be very, very less compared to the fractional change in gain without feedback. So after applying feedback, even if there are changes in the gain, the fractional change will be very less. So after applying negative feedback, the fractional changes will be very less compared to fractional change without feedback. Okay. So these are the two ways to understand how we can stabilize the gain. So the advantage of negative feedback is stability of gain. Fractional change in gain with feedback is very less compared to fractional change in gain without feedback. After this, we are having two important definitions. One is desensitivity and other is sensitivity. Desensitivity is denoted by capital D. Its equation is 1 plus A beta. Okay. So we got the equation here, DAF by AF, that is a fractional change in gain with feedback, is equal to 1 by 1 plus A beta dot fractional change in gain without feedback. What is desensitivity equation? 1 plus A beta. So it is written as, if on cross multiplying, this will go there. So it will be 1 plus A beta is equal to dA by A by DAF by AF. So we can remember the desensitivity equation as D is equal to 1 plus A beta, which is also equal to dA by A by DAF by AF. What is this one? Fractional change in gain without feedback by fractional change in gain with feedback. the fractional change in gain without feedback divided by fractional change in gain with feedback. So that's written in words here. It can be defined as change in voltage gain without feedback to the change in voltage gain with feedback. So this is a desensitivity equation. These two equations you need to remember. Desensitivity is equal to 1 plus A beta. Next definition is sensitivity. It is sensitivity is equal to 1 by D. What is D equation? 1 by 1 plus A beta, which is equal to DAF by AF by dA by A. This is sensitivity equation. S is equal to 1 by 1 plus A beta, which is equal to DAF by AF by dA by A. So how it is sensitivity defined? It is the inverse of desensitivity, or it can also be defined as fractional change or change in voltage gain with feedback divided by a fractional change in gain with feedback to the fractional change in gain without feedback is known as sensitivity. So by this we complete the topic stability of gain in negative feedback. I hope you have understood the class. If you have any queries, you can post in the comment section. Thank you. Good luck, students.